Welcome to the MySQL Developer Essentials series. In this episode, I'm going to talk about the various ways you can optimize and manage cost when running applications and MySQL databases in Azure. If you are running your application and your databases in a Linux virtual machine or a set of several virtual machines, it is very common to over-provision the environment to be able to handle peak workloads. Depending on the type of application you have, the virtual machine may be providing decent performance and response times for the users of your applications most of the time, but cannot really handle a situation when you have lots of incoming requests and concurrent users accessing the application simultaneously. Therefore, you may provision a larger VM just in case, and that costs money. Adding more virtual machines to have a high availability configuration will increase your costs, and you will also be expected to configure and use proxy solutions like ProxySQL, MaxScale, or HAProxy, which all add complexity to the solution architecture. They all leverage semi-synchronous replication of MySQL, which is not really a true high availability solution, but more for building a scale-out configuration. There are also hidden costs that are related to time-consuming tasks you must do to manage kernel updates, security patches, and updates to all the tools you are using in your environments. This is why managed database services such as Azure Database for MySQL Flexible Server are so popular among developers and database administrators. Instead of configuring and managing the infrastructure and the software needed to run a MySQL database instance yourself, you can provision a fully managed database instance in Azure and get the added benefits from Azure to optimize the performance of your databases. You can also optimize the availability of your MySQL databases by configuring high availability with automatic failover using one of the two high availability architectural models: zone redundant high availability and same zone high availability. These high availability configurations are built-in features of Azure Database for MySQL Flexible Server. Additionally, you will be able to scale compute and storage independently based on your workload, and you only pay for what you use. For example, the compute billing tier is stopped immediately when Azure Database for MySQL Flexible Server is stopped. This can allow you to have significant cost savings during development, testing, and for time-bound predictable production workloads. During the time your server is stopped, you are only paying for the storage based on the amount of data you have in your database files, temporary files, transaction logs, and the MySQL Server logs. Azure Database for MySQL Flexible Server provides monitoring of servers through Azure Monitor. Flexible Server provides various metrics to understand how your workload is performing and how the compute and storage resources are being used over the time. Some of the metrics you can see in Azure Monitor are related to utilization of the CPUs, memory, and disk I/O. Based on this information, you will be able to make educated decisions on how to optimize your workload and if you want to scale vertically by changing compute tiers or scaling horizontally by using read replicas. MySQL Flexible Server offers three different compute tiers: burstable, general purpose, and business critical. Burstable tier is recommended for workloads that don't need the full CPU continuously. Typical examples are development environments, environments where you use MySQL in a proof of concept, and applications with low concurrency workloads. Burstable compute tier gives you a baseline performance that can build up credits when it's using less than its baseline. When the environment has accumulated credits, the performance of your MySQL Flexible Server can burst above the baseline using up to 100% of the virtual CPU when your application and database requires higher CPU performance. General purpose tier is the best for workloads that require balanced compute and memory with scalable I/O throughput. Some examples of this type of workload are servers hosting a web and mobile apps and other enterprise applications. The business-critical service tier of MySQL Flexible Server is meant for high-performance database workloads that require in-memory performance for faster transaction processing and higher concurrency. If you are building an application for processing real-time data, or your application is a high-performance transactional or analytical app, business-critical compute tier is the choice for you. The great news is After you have created a MySQL Flexible Server and run your workload in production for some time, you can change the compute tier and size based on the insights through Azure Monitor. This requires a restart of the database service, but only takes between 60 to 120 seconds. You can also monitor your storage with Azure Monitor and scale up the storage to a larger disk size, all the way up to 16 terabytes. Now that I have talked about cost optimization with Azure Database for MySQL Flexible Server, it is time to talk a little bit about applications. There are different ways to host an application in Azure. Azure App Service allows you to build, deploy and scale web applications and APIs built using PHP, Python, Java, Node.js, .NET and so on. Just like Azure Database for MySQL Flexible Server, Azure App Service improves your productivity by offering a fully managed service with built-in infrastructure maintenance, security patching, and scaling. An easy way to estimate and optimize your app service costs is by using the Azure Pricing Calculator. When you create an app service app or an app service plan, Azure Portal will show you the estimated costs with recommended pricing tiers, included features, and included compute configuration. After you have started using app service resources, you can use the cost management features in the Azure Portal to set budgets and manage costs. You can also review forecasted costs and identify spending trends to identify areas where you might want to make changes. You can optimize costs in several ways, as the costs associated with your app service deployment depend on a few main factors: pricing tier, instance count, and a so-called stamp fee. Higher pricing tiers provide more CPU cores, memory, storage, or features, or combinations of these capabilities. Instance count is related to scale-out configurations, and the stamp fee is a flat fee accrued on your app service environment, regardless of how many apps or worker instances are hosted. You can save costs by hosting more apps on one app service plan, in other words, hosting your apps on fewer app service plans. With Azure products and services, you only pay for what you use. As you create and use Azure resources, you are charged for those resources. Because of the deployment ease to use new resources in Azure, the costs of your workloads can jump significantly without proper analysis and monitoring. The Azure Cost Management and Billing feature tools in the Azure Portal allow you to identify opportunities for workload changes that can optimize your spending. With these tools, you can set spending thresholds, set up cost analysis and budgets, and use the recommendation feature, which shows you how you can optimize and improve efficiency by identifying idle and underutilized resources. The cost management feature shows you less expensive resource options based on how you use the resources in Azure. I hope you enjoyed this episode on cost optimization. In the next video, I'm going to talk about how to migrate your existing MySQL databases to Azure. Thank you for watching.